Welcome back. In this lecture, we will see the port 0 structure, that means the internal structure of port 0. Before proceeding, one point is here. Whenever we want to add this port 0 as an input, means we want to add this pin as an input, then we will return here 0. Whenever we want to play the role of port as an input, we will write 1 here, and whenever we want to make this port as an output port, we will write here 0. This we have to remember. And another thing is control signal. As we know, port 0 that can be used as input output port, and also the port 0 also provides the data lines from A0 to A8. So whenever we will use this port as a address lines, we will put 1, and whenever we want to configure this pin as a input output, we will load 0 here. So for the sake of simplicity, let's say control signal is always 0, and whenever we want to get this port as an input, we will write 1. Whenever we want to make this port as output, we will write 0. Okay, now we will make this port as a output port, means we will write 0 here. To configure port 0 as a output, first internal bus D will be 0. So D latch will give here 0. Its complement here 1 because here Q bar is there. Then after that हमारे पास एक मल्टीप्लेक्सर है 2S1 मल्टीप्लेक्सर. इसको जो इनपुट आता है वो कंट्रोल सिग्नल से, अभी मैंने बताया कंट्रोल सिग्नल क्या होगा, ऑलवेज 0. अगर यहाँ पे 0 है, यहाँ पे 1 है, यहाँ पर 0, यहाँ पर 1, तो मल्टीप्लेक्सर क्या करेगा, ये जो बीट है 1 वो यहाँ पे देगा. Means this multiplexer will pass this bit here whenever we get 0 and 1 here. Whenever we have 1 here, this is F81, this is F82, and because of this AND gate, 0 ANDing with anything will be 0. So this FET will be on because of this 1, and this FET will be off because of this 0. So here, if you observe, we will get this FET is connected to ground, this FET is connected to ground. Therefore, here we will get 0 output, 0 work. So right now we have configured this port as a output port. So if we want to output a bit 1, say 1, let's say what happens. We want to output bit 1 from this pin outside. So 1 is here, this will pass 1 here. Complement of this 1 is 0 here. The multiplexer will pass this 0 here because control signal is 0, and here 1. So 0 1 will pass this 0 to here. So because of this 0, and here also because of ANDing, 0 is here. So because of this 0, this FET will be off, and because of this 0, this FET will also be off. So here we are getting high impedance state. The meaning of high impedance state is neither 0, neither 1. Means here the voltage level is neither 0, neither 1, which is called tri-state or high impedance state. So we want to make this bit here appear here, or to output this bit outside, we need to connect one external pull-up resistor here. What happens, because of this external pull-up resistor, the high impedance state will be pulled at the output VCC, means we will get 1 here. Why? Because of this pull-up resistor. So port 0 needs pull-up resistor to act as a output, and specifically whenever we are providing 1 at the output side. So let's take, whenever we want to send the bit 0 to the output, what happens? Let me just erase this one. Okay, we want to pass this 0 to the outside. So D will pass this 0 here, complement will get 1 here. The multiplexer will pass this 1 to this side, because 0 is coming here, 1 is coming here. Because of this ANDing of 0, this will be 0 always. So if you observe, this FET is on because of this 1, and this FET is off because of this 0. So this FET is on, and if you measure the output voltage or the state, this will be always what? Ground. 0. So we want to pass 0, we are getting 0 here. Okay, because this FET is on. If it is on means ground voltage will be here. So this is 0, and this one is off. So no question about VCC. So let's now make this port as a input port. Let's make it as a input port. For input port, we know, as I told, we need to write 1 here. To configure first, let's understand, I am configuring this pin as a input. So 1 here, that will be 1 here. The complement of 1 is here, 0. In here, the 0 will get passed here, because 0 is here always. And because of this AND, 0 will be here. Okay. Because of this 0, this FET will be off. Because of this 0, this FET will be off. The state here is high impedance state. So state of this port is a high impedance state. So if we want to get input, because we are configuring this port as an input, let's say we want to take input from ADC. हमें ADC से input लेना है. If we are connecting this device, analog to digital converter, if you want to take bit 1 from ADC, at this pin, whenever 1 is written here, this one will override this high impedance state. This one will override this high impedance state. This one will get read from here. Okay, ये जो 1 है, जो हम इस बफर से रीड कर सकते हैं. और अगर हमें इस ADC से 0 लेना है, 0 from this ADC, अगर हमें ADC से 0 लेना है, तो क्या करेगा? ये जो स्टेट है, 0 स्टेट, will override this high impedance state. वो जो 0 स्टेट है, वो डोमिनेट करेगी इसको, हाई इंपेडेंस स्टेट को, और ये 0 हमें यहाँ पे मिल जाएगा. So in this way, we are configuring the port as a input port and output port, and we also saw how we are getting the bits from outside and how we are transferring the bit from inside. Okay, thank you.